Hey there, I'm Ian Douglas. I'm the author of the website techinterview.guide, and I'm here to help people with career advancement and interview preparation. My live stream on Twitch covers topics such as company research, how to build resumes and cover letters, applying for the job, getting through interviews, and what to do during negotiations. I've coached thousands and thousands of people over the years to get jobs at the biggest tech companies in the industry, and I'm here to help you too. The following episode is taken from a longer live stream event and may contain interactions with other people in chat. Check out the end of the episode for more information. Let's get to it. We have an anonymous question from Discord asking, I have 5 years experience as a developer, but I'm not very good at data structures and algorithms. How can I best prepare for interviews, especially for a FAANG company? FAANG companies care a lot about different kinds of things, and a big part of their interview process is going to be something like leak code. And so as much as I'm not a fan personally of leak code, it is kind of a necessary thing to practice, because that is sort of the expectation, especially for FAANG level companies, that you're going to be really good at seeing a prompt and being able to come up with an algorithm on the fly and know the best data structure to use. There are technical challenges that will need, or that are possible to solve with different data structures. And depending on which data structure you choose will influence what we call the time complexity of the algorithm that you build. As an example, there's a technical challenge that I used to ask back in the day, back in like 2012, 2013 kind of range, that basically said, you've got a group of numbers, and I want you to find any two numbers in that group that add up to a target. So if I give you like a random group of numbers and I say, your target is 10, go find me the first two numbers in that group that add up to 10. Well, the way that I've worded that question is I'm very vague about how you're getting that data. And a lot of people assume that the numbers are in an array. And so they start, they imagine it's an array and they start processing it over it as an array. But when you think about what has to happen, you find the first number in the array, and then you have to search through the rest of the array looking for the other number to counterpart that will add up to the target. And so it's what we call an n squared algorithm, because for each of n items in that list, you've got to go look at all the rest of them, kind of like advancing forward through there. So it ends up being an n squared algorithm. If you got a million things in that array, you're doing a lot of, potentially a trillion combinations to try to find what you're looking for. And that's not very effective. It's not very efficient. It'll work, but it'll be really slow. If you use a different data structure, like a hash, or a hash map, then you could structure it in a way that says the value of the number in that group that I said is the key in your hash, and you just set the value to whatever you want, which means you could also just put it in a set and say, if this number exists in the set, then it's there. And you don't have to go search for that program, or like iteratively. You don't have to iterate through all of the keys in the set or in the hash to know if that other number is there. So if my target is 10, and the first number I find is a 4, I just need to know, is there a 6 somewhere else in here? In an array, I've got to literally search everything else in that array to know if there's a 6. In a hash or in a set, I can just say, is 6 a key? And it'll immediately tell me yes or no. I mean, there's a few steps of math involved, but it's what we call an O1 lookup, or an amortized O1 lookup, to figure out whether that key actually exists. And so it's a much, much faster way of doing it. You just take your target, you subtract whichever value you're currently looking at, and then you go see if the subtracted value also exists as a key. And if not, then you move on to the next key and you try from there. And so at most, you pass over that data one time, and then you're doing a whole bunch of other O1 lookups to see whether these other values exist as keys. And so the data structure that you choose influences the time complexity of your solution. Bigger companies are going to care that you have studied that kind of stuff. Now, are they going to ask you that exact question? Probably not. If you're an entry-level dev, though, it's a pretty popular entry-level developer question. And so having an understanding on what a data structure is good for, what it's not good for, where it's commonly used, is going to really help. So that would be the best way that I can offer to prepare, is you don't have to go memorize absolutely everything about how a particular data structure works. You just have to know, what is it good for? What is it not good for? Where is it commonly used? So a hash, it's really good for looking things up when you know the key. It's not as effective if you don't know the key and you have to search through all the keys, but hashes also take up a lot more memory than an array, because a hash is actually an array of linked lists. And there's like math involved of like taking the key and turning it into a value and modulo against the number of elements in that array of linked lists, and then it's checking for collisions. And so there's a lot going on under the hood. And so there's a little bit of extra processing power in there, and there's a lot more actual storage in memory when you're using a hash. And so where is a hash commonly used? Well, it's commonly used when you know that you're looking up a particular key of something. So knowing what it's good for, what it's not good for, and knowing where it's commonly used is going to be a really powerful tool when it comes to figuring out which data structure should I use. From there, figuring out the algorithms, and I talk a lot about this on the stream, around understanding the strategy of how to get to an answer and not memorizing specific algorithms, but understanding when I hear a problem that sounds like, how do I do such and such? You have an idea on the strategy of how to go solve it and not just a memorized solution. You can memorize high-level strategies like a backtracking algorithm. I act on a decision and then I repeat the work, and if it doesn't work out, then I undo a decision. It's every backtracking algorithm in a couple of steps. And so understanding those couple of steps and memorizing that, you can do that. Like, it's a lot easier to memorize just a couple of steps than to try to memorize the actual answer to every backtracking problem out there. That's not effective, and it's not a good use of our brain, frankly. So when the person that asked this question was saying, like, I'm not good at data structures and algorithms, how can I prepare for interviews? If you're going for a FAANG level company, you have to know data structures and algorithms. They're going to be quizzing you on it. They're going to be asking you questions about it, and they're going to expect that your answers choose the most performant data structure or use the memory in the most effective way, and that your time complexity is also kept in check, and that you're not doing extra steps that you don't have to do. That's what their interview process is all about. And if you don't have a good grasp of that, or you can't demonstrate that you have a good grasp of that, you're not going to get a job at FAANG. It's going to be much, much harder to try to get your foot in the door there. So unfortunately, the answer is practice and study. If you're not good at it, you have to practice it and you have to get better at it if you really want those jobs. Now, do you have to go get a FAANG job to feel successful in the tech industry? No, you really don't. I'm going to repeat that. You don't have to go get a job at one of the FAANG companies like Facebook, Google, Apple. You don't have to go get a job there to feel like you are a success. Other people will look at that and go, wow, you're successful because you got a really hard job. You got a really good job going through a really hard interview process. But I think it's a better use of your time and a better use of your energy. Just go get any other job. I think getting a paycheck for any kind of job is a better measure of success than where you're actually working. Go learn a skill, go get a job with that skill. Voila, you are successful, in my mind. Thanks for checking that out. I hope that you found it helpful. I always appreciate feedback, so please let me know what you think. I appreciate any subscriptions, so please tell your friends and colleagues about it as well. Check out the website techinterview.guide for more information about when I'm live streaming and all of my free content. Drop by a live stream anytime to ask questions or message me privately, whatever makes you most comfortable. See you next time.